Son bir sunumumuz daha var kıymetli konuklarımız. Şimdi de dil modelinde zararlı datayı engelleme çalışmasını sunmak üzere Arseniy Sandalov'u davet ediyorum sahnemize. Kendisi sunumunu İngilizce olarak yapacak. Please welcome. Thank you. Here you go.
Good morning, ladies and gentlemen. My name is Arseniy Sandalov. I'm a software engineering student from Altenbosch University, and today I will present my project about mitigating harmful data in large language models. So, the objective of my project is to provide a comprehensive algorithm on mitigating harmful data points from the data set of large language models to provide more safer user experience. So let's discuss dangers which we can have from large language models. So researchers showed that large language models are able to generate dangerous content. For example, in 2024, OpenAI's model was seen generating an output how to make a bomb or explode or weapons. Researchers found out that all major large language models are able to generate dangerous content. So, in addition, large language models are able to generate misinformation, which can affect politics. Another case is chatbot Tao. This chatbot was seen generating toxic and racist content, especially about denying of Holocaust. So, in addition, it was seen to generate stereotypic prompts about African Americans citizens. Lastly, I would like to discuss large language models and copywriting. So there was a case when New York Times opened a lawsuit with OpenAI. They said that their model were trained on copyrighted data of New York Times. So OpenAI model could generate an output which is highly looking like New York Times copyrighted content. So to understand how can we mitigate this issue and how can we change it, we need to understand how it is happening. So firstly, large language models are trained on training dataset which contains a lot of text information from the internet. It can be books, it can be websites, it can be anything. It can be dangerous, for example, websites or copyrighted content. Then, like, we are preprocessing the dataset and training the model. And since our model have some data points which are harmful, our model also can generate harmful output, which can lead to dangerous user experience. So, to mitigate this issue, we should use one of the technique, it's machine learning. So machine learning is the process of deleting some specific data points from the data set and retraining the model, so the performance of the model will be the same as the performance of the model which didn't have any harmful data points. You can see it on the diagram here. So one of the technique of machine learning is the CISA framework. It contains several steps. The first one is to collect a comprehensive knowledge base, the training data set. And then we divide the data set on separate parts. They are called shards. Each shard then is divided on separate slices. And as we can see on down, if we have a dangerous or harmful data point from our slice in a shard, we can then detect it and remove. So after we divided shards by slices, we make isolated training. So each shard is not affecting other shards. And then we aggregate the whole little small models into one final model. So what is the point? The point is that once we detected a harmful data point, we can go back to the slicing part, remove the dangerous slice, and then retrain a small amount of model. So we will not spend so much computational resources and time and energy. So, but how can we understand which data point we should remove? So we can use influence functions. Influence function is a concept from robust statistics. It was presented in 1975. And then in last year, it was presented in the field of large language models. So they are helping us to understand how much a specific data point is affecting the performance of the final model, how much it is performing. So I'm presenting a pipeline. So imagine a user is making a dangerous input. For example, write a step-by-step guide on how to make a bomb. And since our large language model was trained on the data set which contained a dangerous data point, it is of course saying like, okay, I can provide you an instruction. So once we detected a dangerous output from the model, we can report it and then try to run influence function on the prompt from the user, output from the model, and on the slice of the data set. We are trying to find such a slice which is giving the maximum output of influence, so we can understand that dangerous data is contained in this slice. After we detected such a slice, we can remove it and then retrain only small amount of small part of model. We retrain it, and we don't retrain other parts. We don't retrain other shards. So we save energy and save time. After that, we again run the last step, aggregation. We put all small parts of the model together, and we have a final model. So, and after that, user again runs the same dangerous input, like explain me how to make a bomb. But our chatbot, our LLM cannot answer it because we removed such a data point from the data set, so it does not know how to do it. So my implementation was to use only prepared libraries. So I would save time, and the experiment which I did would be reproducible. So I made a CISA training class. You can access it using this QR code. For influence function implementation, I was using PyDVL library. Unfortunately, I faced some limitations with running this experiment. Firstly, CISA algorithm needs a lot of memory because we are saving, every time we are saving the small parts of the model, so we need a lot of place. So I couldn't run it in Kaggle, unfortunately. And if we go through all slices to understand which part is dangerous, we would spend, unfortunately, a lot of time. However, it provides us an algorithm to detect dangerous data points. So these are my references, and this is my contacts. If you're interested in collaborating, I'm open for collaboration. Thank you.
Thank you so much for joining us.